Screencast 20.4, a detailed look at balancing a redox equation. We're oxidizing iron 2 plus to iron 3 plus using dichromate 2 minus, which in turn will become chromium 3 plus. This is a chemical reaction. They don't tell you what the corresponding anions and cations are because it doesn't really matter. Those would just be spectator ions in solution. So let's begin by writing the unbalanced equation, just like they said. Iron 2 plus turning into iron 3 plus, dichromate to chromium 3 plus. The oxidation part here is the number that gets larger. That's iron 2 plus turning into the iron 3 plus. The reduction is the dichromate. It's turning into chromium 3 plus. Let's balance things that need balancing here other than oxygen and hydrogen. We'll take care of that in just a second. But the only problem here is we have 2 chromates here and only chromiums here and only 1 chromium ion here. So let's double up. Let's put 2 on this side. And now we are at least balanced for iron and for chromium. Let's add oxygen and hydrogen to balance the hydrogen atoms here. There is nothing except some oxygen here. So let's add 7 water molecules to this side. And since each water molecule has 2 hydrogens, we'll then add 14 H pluses on the left side. So there's our 7 water molecules. We're balanced with respect to oxygen. There's our 14 H plus. We're balanced with respect to hydrogen. So things are looking pretty good here, except for the charge, perhaps. So we'll add electrons to one side of each half reaction to balance that out. For iron 2 plus to iron 3 plus, we need to add an electron to this side. And that's good. We added 1. Let's add 6 electrons to this to balance that out. So 6 minus, 14 plus, we're 8 plus. We're 2 minus. That makes us 6 plus. And on this side, we're 6 plus. So we're balanced for everything. That's great. Now we are going to combine these, and we better make sure that the electrons cancel overall. So we better multiply this times 6 in order to make it work. So see how we did that? And that'll offset 6 electrons on this side. We'll then combine it, and we should be done. So there it is again. Let's add up the oxidation and the reduction side. It's nice how the electrons cancel because we made them cancel. And we end up with our final balanced redox equation shown here. And don't forget that these must have some counterions that go with it. So that could be one of the reactions where we just randomly added Cl minus and Na plus to make everything work. So this is then verified to make sure that everything is good. We have H balanced, we have chromium balanced, and we do. So everything's balanced out, and we have a detailed solution to a balancing redox equation.